Okay, so how do we use special right triangles to solve problems? So we'll start by taking a look at this square. All right, so what are the properties of a square? Right? Pardon me, the question reads, how long is the blue line? Right, so blue line is the diagonal that runs from two vertices in this square. Right? So the question wants to know how long that line is that's running between these two um, dots. So it's a square. So one of the properties of a square is that all sides are congruent. So each segment is 10 feet, inches, centimeters, yards, whatever the unit of measure is, long. So if I would ignore the top triangle, I have two triangles in this setup. Right? The diagonal cuts the square into two equal triangles. So if I would ignore the top triangle for me, and I just focus on the bottom triangle, well, what type of triangle do I have? It turns out that I have a right triangle where one of the sides is 10, the other side is 10, and there's an unknown side. So each one of these sides are legs. How do I know these are the legs? Well, the side is across from the 90-degree angle as the hypotenuse. So the remaining sides have to be legs. So we have a theorem known as the Pythagorean theorem that tells us that the sum of the square of the legs is equal to the hypotenuse square. Right? In other words, a squared plus b squared is equal to c squared, where a is 10 and b is 10. How do I figure out what c is? C in this case, blue line that we initially had in the problem. Right, so that's c. Okay, so it turns out that this is going to be 100 plus 100. C squared. C squared is therefore equal to 200. Means c is the square root of 200. If I have to write this in simplest radical form, I will change this to the product of 100 times 2. Right, so square root of 100 times square root of 2 is the same as square root of 200. Now, square root of 100 simplifies into the whole number 10. My answer will be 10 radical 2. Right? So special right triangles allows us to take this shortcut. Right? So we could skip from a problem directly to the answer without having to go through the Pythagorean theorem. So let's take a look at the rules. The rule states the following. In a 45-45-90 triangle, both legs are congruent, and the length of the hypotenuse is the length of a leg times the square root of 2. So in an example we had before, we had a right triangle where this leg was 10 and this leg was 10. And our final answer for the hypotenuse was 10 square root 2. So what the theorem is saying is the length of the hypotenuse is always going to be equal to whatever the legs are times radical 2. All right, so as we just proved in the previous example, that the length of the hypotenuse is always going to be equal to whatever the leg is, whatever measure the leg is, times the square root of 2. Okay? So let's see how that applies to a typical problem. Finding the side lengths of the 45-45-90 triangle. Question reads, find the value of x. So this is my goal. All right, find out what x is equal to, in other words, solve. Give your answer in simplest radical form. Well, my approach for all these problems are the same. The very first thing I want to do is mark up the triangle. So I'll draw an arrow away from the 90. I know that's my hypotenuse. I know these two legs are congruent because it's a 45-45-90 triangle. If this is 45, then that means this must be 45 as well. All right? Because all these angle measures have to add up to 180 degrees. So if this is 7, then this is 7. So 45-45-90 triangle, the one shortcut that's associated with it is that the hypotenuse is equal to the leg times the square root of 2, whatever the measure of the leg is. Hypotenuse in this case, I can replace it with number or value. Hypotenuse is x. Leg in this case is 7 times the square root of 2. So x is equal to 7 radical 2. This is also already in simplest radical form. So I answer the question. The value of x is 7 radical 2. It's a straightforward example. Find the value of x. Once again, give your answer in simplest radical form. Same approach. So that's my hypotenuse, and these are legs. So how do I know that this is a 45, 45, 90? Well, the legs are both congruent. They're both x. All right, so x is some number, but whatever it is, both legs have to be the same number. All right, so we will state the hypotenuse is equal to the leg, the length of one of the legs times the square root of 2. The hypotenuse in this case is 3. It's equal to, the leg in this case is 8 times the square root of 2. Okay. We're solving for x, which is the goal of the problem, find the value of x. So we'll divide both sides by the square root of 2. So the square root of 2 cancels out the square root of 2. That leaves me with x. And on this side, I have 3 divided by the square root of 2. Now that's not in simplest radical form because we have a square root, a radical in the denominator of a fraction. In all of mathematics, it's not allowed to leave a radical in the denominator of any fraction. So we have to take one more step to rewrite this fraction 3 over radical 2. So there's no radical sign in the denominator. And the way in which I do that is as follows. I would say if I have 3 over square root of 2, and I multiply it by the whole number 1, I'm not changing the value. I'm still retaining its value of 3 over 2. So multiplying by 1 didn't change it in any way. But I'm going to choose how I write the number 1. So if I do 3 over the square root of 2 times 4 over 4, for example, well, 4 divided by 4 is just a fancy way of writing the number 1. So I expect my answer to be unchanged. It's still 3 over square root of 2. This allows me to write my solution as follows. If I have 3 over the square root of 2 multiplied by the square root of 2 over the square root of 2. Once again, this is just a fancy way of writing the number 1. Anything divided by itself is 1. So I'm not changing the value in any way. Okay. So if I have 3 over the square root of 2 times the square root of 2 over the square root of 2, I get the following. I multiply the numerators together, I get 3 radical 2. I multiply the denominators together. The square root of 2 times square root of 2 is the square root of 4. Square root of 4 is the whole number of 2. So 3 radical 2 over 2 is my answer. And this process is called rationalizing the denominator. Alright. So now we have rewritten the fraction 3 over the square root of 2 to look like the following. And if you have the time, you could check. You could put into your calculator, you can do 3 divided by the square root of 2, hit equal. It's going to give you a decimal answer. And then you can do 3 square root 2 over 2, hit equal, and you'll realize that the answers are the same. So in other words, the value of those two objects are totally the same. These two objects are equal to each other in every way, just written differently. Right? And for our purposes, we must write it such that there's no square root sign, no radical sign in the denominator. All right, so our answer for this problem is 3 square root 2 over 2. All right, so here are a couple more examples. I'll go through them really quickly. You can pause the video and try to do these on your own, and then compare it with the solution that I'm about to show. Find the value of x, give your answer in simplest radical form. Okay, let's go. So the process is the same. All right, so my hypotenuse is equal to the leg times the square root of 2. Leg in this case is, hypotenuse in this case is x. Leg in this case is 10 radical 2 times radical 2. How do I simplify that? This means 10 times the square root of 2 times the square root of 2. If I would ignore the 10 for now, that gives me 10 times the square root of 4. If I multiply the square root of 2 by the square root of 2, I get the square root of 4. Square root of 4 is the whole number 2. So 10 times 2 is equal to 20. So my answer for x in simplest radical form, x is equal to 20. 1b. start the same way. So this is my hypotenuse. This is my leg. This is my leg. I know that this is a 45, 45, 90 because it's written here. In the previous example, I know this is a 45, 45, 90 because these angles are congruent. A little arc right there and there tells me those two angles are the same number. And the only possibility is that when they're both 45. All right, so I can go ahead and set this up as follows. My hypotenuse in this case is 16. The leg is unknown, that's x times radical 2. Continuing, I could say divide both sides by the square root of 2. Square root of 2 cancels out, leaving me with x is equal to 16 over radical 2. In the previous example, we said it's not acceptable to leave a square root sign in the denominator, so I need to take this and convert it. Rewrite it such that the square root of 2 is not there. To do that, I would multiply by the square root of 2 over the square root of 2. 16 square root of 2 is what I get when I multiply the numerators, and the whole number 2 is what I get when I multiply the denominators. 16 by 2 is equal to 8, so my answer is 8 radical 2. X is equal to 8 radical 2. Okay, so moving into the next concept of the 30, 60, 90 triangle. In the 30, 60, 90 triangle, the length of the hypotenuse is twice or 2 times the length of the shorter leg, and the length of the longer leg is the length of the shorter leg times the square root of 3. All right, so if these numbers look like this, if AC is 5, then the hypotenuse is going to be 10 because the hypotenuse is double the length of the short side. If the short side is 5, then the long side is going to be 5 radical 3. And that's what, once we can identify a triangle, a right triangle as being 30, 60, 90, we could go ahead and use these two shortcuts. Okay. How do I know which side is the short side, which side is the long side? Well, I'll look at my angle measures. So across from the 30-degree angle, the side that's across from the 30-degree angle, well, that has to be my shortest side, my shortest leg, because 30 is smaller than 60. Across from my 60-degree angle, well, this has to be my long leg, because 60 is larger than 30. And the remaining leg, well, that's across from the 90-degree angle, which is the way we usually start. So that has to be my hypotenuse. So we quickly identify the short leg, the long leg, and the hypotenuse. Okay, so let's take a look at a couple of problems. Find both values, x and y, give your answer in simplest radical form. All right, so there are two formulas that's associated with the 30-60, when we find the side lengths of the 30-60-90 triangle. All right, first is the hypotenuse is always equal to the short leg times 2. The second formula is the long leg is equal to the short leg times the square root of 3. We then look at our problem and see which pieces we have, right? Where do we have numerical information? That's a question you should keep asking yourself. Well, I have numerical information for the following. I'll just look at my triangle and I'll start populating things, right? So I'll say right across from my 90, that has to be my hypotenuse. Right across from my 30, this has to be the short leg. Right across from the 60, this has to be the long leg. So I have numerical information for the hypotenuse. Then I would look at both formulas, formula 1, formula 2. And I ask myself, which one has anything to do with the hypotenuse? And that's clearly formula number 1. So I'll start there. I replace hypotenuse with the number 16. My short leg in this case is x times 2. Divide both sides by 2. X is therefore equal to 8. That's half of my answer. Second half of my problem says find y. Well, the long leg is y, so that's replaced by the letter y. My short leg, I figured out that it's actually 8 in my first step of the problem, times radical 3. So my answer is y is equal to 8 radical 3. Well, that's pretty straightforward. Okay, next. We have the same setup, a 30, 60, 90 triangle. So I know that the hypotenuse is equal to the short leg times 2. And I know that the long leg is equal to the short leg times radical 3. So I've written my shortcuts down, my equations down. Next thing I'm going to do is mark the triangle up. So across from the 90 is the hypotenuse. Across from the 30, that's going to be my short leg. And across from my 60 is going to be my long leg. All right. The next thing I do is ask myself for the short, the long, and the hypotenuse, which of these I have numerical information for. I have an 11 representing the long. So I'll take a look at both of my equations and say, well, equation number 2 has the word long in it, so I'll use that one. That's where I'm going to start. So I'll say 11, replace long with 11, is equal to short. Short is actually x times radical 3. Solving for x, I will divide both sides by radical 3. Square root of 3 cancels out. I get x is equal to 11 over radical 3. We cannot leave it in this form, so I will multiply it by the square root of 3 over the square root of 3. Multiplying the numerators, I get 11 radical 3 over 3. That gives me the value of x. I need to find out what y is equal to. I go to the other formula that says the hypotenuse, which is y, is equal to the short, which is 11 radical 3 over 3 times 2. So the number in front of the radical sign is going to be affected by that 2. So 2 times 11 is going to be 22. Square root of 3 stays put. The entire thing was over 3. That's my answers. Y is equal to 22 radical 3 over 3. X is equal to 11 radical 3 over 3. So that's pretty much the approaches. Okay. So let's take a look at a couple of problems. I will do, great. I will do, I'll do them all. So I encourage you once again to do these problems before looking at the answers and then just checking in with the answers as I put them up. So 3A, let's make a slide for each one of these problems. One more, great. So 3A, we have that's a 30, 60, 90 triangle because even though they didn't write the 30 in, I know the angle measures have to add up to 180. 60 and 90 is 150. 150 plus 30 is equal to 180. If I said 190 before, please forgive me. I meant to say 180. All right. So now the next thing I do is set up my equations, right? So I know the hypotenuse is equal to the short times 2. I also know that the long leg is equal to the short times radical 3. Okay. Next thing I do is mark up my triangle. So I identify that this is the hypotenuse. I identify that this is my short. This is across from the 30. And I identify that this is my long. Right, and that really helps me. Instead of trying to keep it all in my head, write it down. Right, so hypotenuse is 18 radical 3, so I could replace that with a number. Short is x times 2. Divide both sides by 2, and I get the following. 2's cancel out. X is equal to, let's take a look at the whole numbers. 18 divided by 2 is 9, and we just bring down the radical 3. So x is equal to 9 radical 3. If x is equal to 9 radical 3, then long, which is y, is equal to 9 radical 3 times radical 3. Okay. So we get 9 times radical 3 times radical 3. If I rewrite 9 square root of 3 in that way. So the square root of 3 times the square root of 3 is going to be equal to the square root of 9. The square root of 9 is equal to the whole number 3. So 3 times 9 is equal to 27. Y is equal to 27. Okay, so 3B. Once again, we have to find the values of x and y and give your answers in simplest radical form. All right, so step 1, let's write down the two formulas. We know that the hypotenuse is equal to the short leg times 2. We also know that the long leg is equal to the short leg times radical 3. Step 2 is to mark the triangle up. So we know that directly across from the 90, that's going to be a hypotenuse. Directly across from the 30, that's my short leg. Directly across from 60, so the long leg. And the question is, how do I know that this angle is a 60-degree angle? Well, if this is 90 and this is 30, 90 plus 30 is 120. 120 plus 60 is going to be 180. So that's how I know that this angle is going to be 60 degrees. All right, so we have all sides marked up as a hypotenuse along the short. Now, the next step is to identify which of these two formulas I'm going to use. So once again, you should have a running narrative at the back of your head. Which of these sides do I have numerical information for? And it turns out that the short side has a value of 5. Now, both formulas have the word short in it, so it makes it very easy. So the hypotenuse in this case, which is y, is equal to the short leg, which is 5 times 2. So 5 times 2 is 10. The long leg is x. The short value is 5 times radical 3. So x is equal to 5 radical 3. So in this case, it didn't matter which of the two sides, what formula I start with, because we had information for short leg. All right, so x is 5 radical 3, while y is 10. Okay, let's move on to 3C. Same deal, we start off with our formulas. See, hypotenuse is equal to short times 2. Long leg is equal to short times radical 3. We start marking it up. This is my hypotenuse. This is my short. And the remaining leg is the long. Okay. Ask myself, which of these do I have numerical information for? And that's the hypotenuse. So the only formula that has anything to do with the hypotenuse, the only equation will be equation number 1. So I replace hypotenuse with the number 24, short with the letter x times 2. To solve, I will divide both sides by 2. X is equal to 12. 1/2 of my answers. The other half would say I would need the second equation. Long is equal to short times radical 3. Long in this case is y, so I do that substitution. Short is equal to x, which is equal to 12. So it's 12 times radical 3. All right, so y is therefore equal to 12 radical 3. And the final problem of this group is 3B. Formulas in the first step. Once we know it's a 30, 60, 90 right triangle, we could use the following. Okay. Step 2, mark up the triangle. Oops, I might be falling apart there. Okay. I have numerical information for the long leg, so I'll be using equation number 2 first. So long in this case is 9, is equal to short, which is y, times radical 3. Divide both sides by the square root of 3. I get canceling out. Y is equal to 9 over radical 3. We know from previous examples that we can't leave the fraction written in this form. That's not simplest radical form. So we have to simplify it by multiplying by the square root of 3 over the square root of 3. This becomes 9 radical 3 when I multiply the numerators. The square root of 3 times the square root of 3 is the square root of 9. The square root of 9 is therefore the whole number 3. Okay, so we have 9 square root of 3 divided by 3. This can be simplified further if I look at the whole number that's outside of the radical sign. So 9 divided by 3 is 3. So this entire thing simplifies to 3 radical 3 as the value of y. If y is 3 radical 3, then we can write the following. Hypotenuse in this case is x. My short leg, which is y, is equal to 3 radical 3. And the whole thing is multiplied by 2. So if I look at the whole numbers, I could say that x is equal to 2 times 3 radical 3. I write a 2 at the front. 2 times 3 is equal to 6. So my answer is 6 radical 3. Okay, so we have some more problems, and I will just let you guys work through these. But we are at the end of the lesson. It's more of the same. This is an example of a 45-45. This is extra problem, guided practice problems. A 45-45, 90. This group. All right, how do I know it's 45-45, 90? Well, one of the angle measures is 45. There's a 90-degree angle already there, so the remaining one must be 45. These two legs are congruent, so that makes this a 45-45, 90. There's a 45 already present. This must be 45. All right, so we'll go ahead and apply the hypotenuse is equal to leg times square root of 2 for these three problems. And we've done similar problems in the same video, so I would stop the lesson at this point and wish you guys luck on getting the exit tickets done. Please make use of this resource, come back to it, pause, rewind, look at it, and see how I take the problems apart, see how I set the problems up. And if you have any questions beyond this, please feel free to come and find me during AIS. Good luck.